Good morning, mathematicians. Today we're going to look at adding and subtracting fractions. And let's take a look at our page. Our page number here is 4L. So if you're adding to your notebook, you could put this as 4L, and the page on the right is 4R. Let's take a look at our objective. I will use a multiplier to add and subtract, unlike fractions. Looks like I'm missing a period there. One more time, read it with me. I will use a multiplier to add and subtract, unlike fractions. Now, when we talk about unlike fractions, we're talking about two fractions where the denominators are unlike one another. And for adding and subtracting fractions, I need you to imprint this in your brain. Keep it in there, because it's vastly different from when we multiply and divide. We need to think about it, and we need to know it. So, however we can get this information into our brains and keep it there, we need to. You need like denominators to add and subtract fractions. Must have like. If they're unlike, we have to do something about it to turn them into like denominators. If you were in my live session on, I don't remember what day it was, Wednesday, we talked a little bit about using a multiplier, and I'm going to jump into that more now. Vocabulary. Multiplier. A multiplier multiplies. It's right in the name. So, it is a number multiplied by the numerator and denominator to increase a fraction. And when I say increase, I mean the size of the number, not necessarily the size of the piece in the fraction. For instance, we could have a denominator of 2 and increase it to a denominator of 8 if we used a multiplier of 4. So we're going to increase the numerical value of the number, not necessarily increase the size of the fraction. So let's look at one sample problem here. This is a change one scenario. So my sample problem is here. I've got 3/10 plus 1/2. And thanks to my message up here, I need like denominators. I can't actually do this problem as it is. So I need to change one of them. So I've decided to change my 1/2 because I can turn a 2 into a 10 through multiplication. I got a cat trying to get in here. So I'm going to keep my 3/10. I'm going to change my 1/2. So to change my 1/2, I pull it out of the problem. Now, how do I go from a denominator of 2 to 10? I need to multiply. What are my 2's? 2, 4, 6, 8, 10. So it's 5. Now, if I do it to the bottom, I have to do it to the top. And this is where my multiplier becomes the number 5. So 1 times 5 is 5/10. Now I have a new fraction, and a kind of sloppy 5 there. I have 5 over 10. Now I have the same denominator as my first addend. So let's go ahead and add them together. 5 plus 3, I can do it. I get 8. And here's the other thing we have to remember. The denominator doesn't change in the answer. The reason we need like denominators as addends is that the answer will be the same denominator. So we're not actually adding the denominator. And again, you've got to know this for adding and subtracting, because when we get to multiplying and dividing, it's totally different. All right? So this is an example of changing one addend or one subtrahend. Ooh, fireworks. What a season we're in. All right, here's a scenario where we need to change both. I cannot turn a 7 into a 3 through division, and I can't turn a 3 into a 7 through multiplication. So what I need to do is find a number that they both can turn into. We can do this one of a couple of ways. One way would be to simply list our the numbers we can create with them through multiplying or multiples. So I can use my 3, 6, 9, 12, 15, 18, 21, 24, and I can keep going and going and going. What we're looking for is we're going to look for a number where they match. And let me switch my color here for a moment. Let's go with our other denominator of 7, 7, 14, 21, 28. Now, as soon as you hit a number that they share, that's when we can stop. And I actually know which number we're going to land on right now. It's going to be 21, 21. So this is the first number that they share. So now I want to make this problem a problem where the denominators are 21. Now, this method will always work. However, this method takes a lot of time. That's my poor attempt at a clock. Time. What I'm suggesting is we use the existing problem and use the denominators. So for instance, if I pull down my 6/7, I'm going to use the denominator of 3 to multiply by 6 and multiply by 7. So for this fraction, my multiplier is 3. For the other fraction, 1/3, I'm going to come over here, 1/3. I'm going to use 7 as the multiplier. And you can see what I've done down here. Let's start with 6/7. 6 times 3, 7 times 3. Come down, 1 times 7, 7 times, or 3 times 7. What we're going to end up with is 18 over 21 and 7 over 21. Now we have a problem we can work with. Here we go. We've got 18 21s minus 7 21. We end up with 11 21. Now, take a look. There's a lot that goes in here. Many of you are going to be able to skip these steps and be able to do this right in your head. But these are all the steps we have to work out. So individually, one fraction, the second fraction. So it's a lot of steps built in, but you can utilize the denominator of one fraction as the multiplier. Excuse me. Whew, that was a good sneeze. All right. Let's take a look. What's next? All right, we'll keep this up for one moment. And again, this is a change both. Change one, change both. You can always change both. All right. Next one. How do I reduce a fraction? Now, this is going to be a question you're going to see in Prodigy. Reducing means making the fraction as small as it can be. And for this example, I have a fraction of 10 over 20. It can get smaller. So what I want to do is use a divisor. Now, this is very similar to the multiplier we use to make a fraction bigger. Using a divisor by both the numerator and denominator will get us to its smallest form. So let's test it out. What number can 10 and 20 be divided by? Oh, Mr. McNeil, they're both they're both multiples of 5. Sure, let's try that. 10 divided by 5 is 2. 20 divided by 5 is 4. We're almost there. What else could they be divided by? Well, we could say 2. Let's try it with 2. 10 divided by 2 equals 5. 20 divided by 2 equals 10. Ooh, see, we're still not at the smallest point. Sometimes one of the numbers, typically the numerator, is the number you divide by. So really, to get this as small as humanly possible, we'd have to do 10 divided by 10 equals, how many 10s fit in 10? 1. 20 divided by 10 How many 10s fit into 20? Equals 2, or a half. So what we end up with is 1/2 is equal to 2/4 is equal to 5/10 is equal to 20 or 10/20. What we have to do is take that fraction we started with and get it as small as possible. And we're going to do that by finding the biggest divisor. So 2 is not going to work for us. 5 didn't work for us. 10 was the divisor that worked. All right. Good luck, mathematicians. Have a great day.